Welcome to the faculty advising process for the Department of Civil and Environmental Engineering. Our undergraduate programs in civil engineering and in environmental engineering provide a range of advising resources, including annual faculty advising. To increase accessibility to these advising resources, we provide online video copies of the faculty advising slides used with group faculty advising sessions. The group advising slides are organized in separate modules. Modules 1 and 2 presented an overview of civil and environmental engineering careers and of the faculty advising process. Next, in Module 3, we present an overview of the BS in Civil Engineering program. The objective is to complement the advising provided by School of Engineering undergraduate counselors and, importantly, to identify any program changes that may impact your path to your degree. Only students majoring in civil engineering need review these slides. Subsequent modules cover the BS in Environmental Engineering program and student support programs. The following slides present the Bachelor's of Science in Civil Engineering program. We'll follow the outline shown, but feel free to jump to sections with details on any portion of the program for which you need information. Small but important changes are often made to the program, so it is to your advantage to be aware of these changes because they can benefit you. Catalog rights. Remember, the general catalog corresponding to your first year enrolled in one of our programs contains the requirements that you must follow to complete your degree. You are free to change to a program in a different catalog year, but you must assume all the new requirements. You can't mix and match. For example, assume that in next year's catalog a required course was dropped and a new one added. If you switch catalogs, you would need to take all the new requirements, and old program requirements may or may not still be in force. Program educational objectives are the longer-term accomplishments that each program graduate will reach. They are our aspirations for your career that will be achieved only after you have received your degree and are no longer being actively taught by us. They are comparable to the basic characteristics that your parents likely have instilled in you before they sent you off on your own to college to become the best that you can be. The program educational objectives for the Bachelor's of Science in Civil Engineering include the following. 1. Establish a civil engineering career in industry, government, or academia, and achieve professional licensure as appropriate. 2. Demonstrate excellence and innovation in engineering problem-solving and design in a global and societal context. 3. Commit to lifelong learning and professional development to stay current in technology and contemporary issues. And 4. Take an increasing level of responsibility and leadership in technical and/or managerial roles. Unlike program educational objectives, student learning outcomes, or SLOs, are controlled by your degree program. These are broad descriptions of the abilities that you must have before you can graduate. While keywords are accentuated, the entire language is important and expressed concisely. By graduation, all students must have the ability to 1. Identify, formulate, and solve complex engineering problems by applying principles of engineering, science, and mathematics. 2. To apply engineering design to produce solutions that meet specific needs within consideration of public health, safety, and welfare, as well as global, cultural, social, environmental, and economic factors. 3. To communicate effectively with a range of audiences. 4. To recognize ethical and professional responsibilities in engineering situations and make informed judgments which must consider the impact of engineering solutions in global, economic, environmental, and societal contexts. 5. To function effectively on a team whose members together provide leadership, create a collaborative and inclusive environment, establish goals, plan tasks, and meet objectives. 6. To develop and conduct appropriate experimentation, analyze and interpret data, and use engineering judgment to draw conclusions. And 7. To acquire and apply new knowledge as needed, using appropriate learning strategies. In each engineering course that you take, one or more of these SLOs will be linked to specific course outcomes expressed in terms directly related to the course in question. For an example, see the next slide. In addition to program educational objectives and student learning outcomes, we also have course learning outcomes. Shown as part of the course syllabus for CEE 20, a core course taken in the second year. Note that this particular course relates to 4 of the 7 student learning outcomes defined on the prior slide. Also note that the syllabus identifies specific course learning outcomes, each tied closely to course material, but also linked to one or more student learning outcome. For CE20, there are 7 course learning outcomes, each linked to a specific student learning outcome. All engineering programs include a significant amount of math and science coursework, and civil engineering is no different. Note that all program courses are currently taught as 10-week quarters. In general, 2 years of calculus through differential equations is required, as well as a course on engineering probability. Our program also requires 2 courses in physics with labs and 2 courses in chemistry, as well as a science elective from another area of science. We also require 2 additional lower division science or engineering science electives from the list of options shown on the slide. All undergraduate majors at UC Irvine must complete a general education requirement. All undergraduate majors at UC Irvine must complete a general education requirement. The above program requirements cover those parts of general education corresponding to math and science, but an additional 44 units in specified areas is required, and this is covered in a later slide. Last, our program requires several engineering professional topics classes, but each overlaps with a general education requirement, so, while care must be taken to complete those courses, no additional courses must be taken. The largest portion of the BSCE program is unsurprisingly civil engineering courses. In the lower division, your first 2 years, in addition to the math and science requirements, you will take 5 core courses, CE 20, 21, 30, and 81A and 81B. Note that in our BSCE program, courses that end in a 0 or a 1 are required. Also note that courses that end in a 0 can be considered the most critical and that they serve as prerequisites for many subsequent courses. These include CE 30 in the lower division and CE 110, 150, and 170 in the upper division. The best way to review these requirements might be by viewing the plan of study for each provided in the subsequent slides. In addition to these core courses, there are 2 other requirements featured in our BSCE program. The first is that every BSCE major must select a specialization and must also complete a senior design practicum. These are discussed in subsequent slides. Please note a recent change. To enroll in CE 150, a junior year core course, now requires a grade in CE 30 of C- or better. The full BSCE program has a nominal total of 184 units. We've indicated design units as part of this requirement, but students do not need to pay attention to this since our core courses automatically include the necessary design units. This slide displays a typical first-year program. There is some flexibility in the first year of study, although this is primarily due to the amount of advanced placement with which students enter the program. For example, many of our students enter with credit for the first 2 math courses. In addition to the flexibility provided by the choice of general education electives, BSc majors will select a science elective and 2 lower division engineering electives, one of which tends to be in the first year of study. Many of our students enroll in Engineering 7AB, which involves the design, build, and testing of a defined technology such as a quadcopter. A word of advice. Grades are important. A successful performance in the first year math and science courses will provide you with the skills necessary to succeed in subsequent courses. Your grade is a measure of your success. Let's take a look at the second year. A typical schedule for the second year continues math courses, including CEE 11, and adds lower division BSCE core courses, including CEE 20, 21, 30, and both 81A and 81B. It also completes the lower division engineering elective requirement. For the LDEE, many of our students take MAE 80 Dynamics as a complement to the required course CEE 30 Statics. There are also a few slots for general education courses, and remember, lower division writing requirements should be completed by the end of the second year. The Year 3 sample program represents the core of the civil engineering curriculum. During this year, students complete a year of structural engineering courses, 150, 151A, and 151B, a year of water and environmental engineering courses, 170, 171, and 160, and required courses in transportation, 121, soil mechanics, 130, and 1 course in project management and engineering economics, 110. These courses serve as prerequisites for senior year electives in the various specializations, so you should give consideration to which courses are of greatest interest to you, since you might want to specialize in that area in your senior year. Students should also try to complete the upper division writing requirement. Most of our students complete Engineering 190W. The sample program for Year 4 features both the year-long Senior Design Capstone Sequence, CE 181, A, B, and C, as well as your choice of a specialization. These two features are linked. You must complete a senior design project in the area of your specialization. Note that many of the senior electives are design-oriented, but they depend on the knowledge and skills mastered in prior years. Many third-year courses serve as prerequisites for senior year electives. If you do not successfully complete certain third-year courses, you may be precluded from certain specializations unless you are willing to return for a fifth year. For example, without CE 151A in the third year, you will not be able to take the fourth-year structural electives. Note that most of our courses are only offered once per year. The exceptions are CEE 30 and CEE 150. These courses, and by demand other lower division courses, are usually offered in the summer session as well. The BSCE degree program requires that each student select a specialization. Two of the four choices are General Civil Engineering and Environmental Hydrology and Water Resources. Each specialization requires 4 courses. The General Civil Engineering specialization draws courses from each of our specialization areas. As such, it is not really a specialization, but it does correspond to what many other civil engineering programs have as a degree requirement. Pick 1 or 2 courses from each area. The 4 areas to choose from at UCI are Transportation Systems, Structures, Environmental, and Water Resources. To complete the specialization, you must choose at least 1 course from at least 3 of these areas. The specialization in Environmental Hydrology and Water Resources requires a choice of any 4 courses from Environmental Engineering, the 160 series, or from Water Resources, the 170 series. Note that this 4-course specialization is not equivalent to the BS in Environmental Engineering degree program. You can see our Faculty Advising video module 4 for more details on that program. In fact, the term specialization is used by the university to represent a group of courses drawn from the same general area. Students should look at this as the opportunity to take courses where their interests are greatest, rather than assuming that they are specialized in a particular subfield of civil engineering. In fact, in most cases, our students are qualified to work in any area of civil engineering after graduation, regardless of their chosen specialization. The BSc program requires that each student select a specialization. The other 2 of the 4 specialization choices are in Structural Engineering and Transportation Systems Engineering. Each specialization requires 4 courses, but unlike the first 2 specializations, each of these has specific course requirements. The specialization in Structural Engineering requires CE 155 Steel Design and any 3 other structural engineering courses. The specialization in Transportation Systems Engineering requires both CEE 122 and CEE 123, and another 2 courses in transportation or related areas. Roughly speaking, about 25 to 35% of our students specialize in either structures, transportation, or water, with the remaining specializing in the general area. The Senior Capstone Design Sequence is actually common to both our BSCE and our BSENE programs. There are 2 components. In the fall quarter, in CE 181A, interdisciplinary student teams work with the Irvine Company to plan the land use and the associated civil infrastructure of a sub-area in the city of Irvine. By interdisciplinary, this means that at least 1 student from the BSENE program is joined up with a student in structures, a student in transportation, a student in water, and a general student to form an overall team to do the overall planning effort. In the winter and spring quarters, CE 181BC, specialized student teams work with an industrial affiliate to design a specific infrastructure element, such as a bridge, a building, a roadway or transit system, or a water supply or control system. By specialized, this usually means that all the students on your team are structural specialization students if you're doing a structures project. They're all transportation specialized students if you're doing a transportation project. There are exceptions to these based on the multidisciplinary nature of some of the projects that we do. UCI has rather extensive general education requirements. Engineering programs automatically cover 2 of these areas, Math, Area 5, in Science Area 2. Both the BSCE and the BSENE programs have professional topic requirements which overlap with the General Education Area 3 requirements. Note that these requirements can only be satisfied with a letter grade, so do not take any of these courses graded as pass, no pass, since you may not be able to graduate. Also note that a passing grade requires at least a C grade, otherwise a no pass is assigned. General Education Area 1 is writing and requires 2 lower division and 1 upper division course. Most engineering programs require Engineering 190W as the upper division course. This course focuses on technical writing and presentation. Ideally, you will take this course as early as possible so that the writing skills acquired can be applied in other courses such as senior design. Note that students can petition to take a different upper division writing course. There are 2 excellent sources of information regarding general education. First, the School of Engineering undergraduate counselors have been advising School of Engineering students for years and can direct you toward courses of interest. Second, your upper-class peers have already taken many of these courses. The best way to meet them might be through student clubs. As mentioned before on these slides, prerequisites are critically important. They are not some unnecessary hurdle that students must negotiate to proceed through the degree program. They are opportunities to obtain knowledge and skills that are needed in subsequent courses. Also, grades are important, not because your GPA is some critical achievement that will be viewed by employers, however minimum GPAs are required for grad school, but because they indicate how well you have captured the knowledge and skills that you need to know for the next step in the program in your career. Grades are indeed important. In general, course numbers that end in 0 or 1 are critical for you to maintain progress through the program. This includes courses such as 11, 20, 30, 110, and in particular 150 and 170 in the upper division. As an example of prerequisite chains, we've displayed that for our senior capstone design sequence. That's 181A and 181BC. Not surprisingly, our senior level cumulative design experience relies on the knowledge and skills from most other courses in our program. But this diagram also shows the connectivity between various other courses. We graduate over 100 students each year in our civil and environmental programs. To be one of these students, you need to stay on the prerequisite path. While some of our lower division core courses are offered multiple times per year, including in summer, most of our courses are offered only once each academic year. They should emphasize the importance of developing a plan of study with a counselor prior to the start of each academic year. Those of you just starting in our program may not be aware of the Fundamental of Engineering exam. Those later in the program may actually have taken it already. The so-called FE exam is offered by the National Council of Examiners for Engineering and Surveying, and it's designed for recent graduates and students who are close to finishing an undergraduate degree program from an ABET accredited college. The FE exam is computer-based and is administered year-round at approved test centers. The exam includes 110 questions and takes 6 hours. To gain registration as a professional engineer, which you need in order to practice in civil engineering, you must first graduate from an ABET accredited engineering program and pass the FE exam. These 2 should be completed when you graduate from UCI. Then, after 1 to 2 years of engineering work under the supervision of a professional engineer, you must pass the Principles and Practice of Engineering exam, the so-called PE exam, which tests for a minimum level of competency in a particular engineering discipline. Full information on both the FE and the PE exam is available from their website. Note that these 14 areas shown for the CE exam are covered throughout the various courses in our program. This completes Faculty Advising Module 3, an overview of the BS in Civil Engineering program. BSCE majors can skip the module on the BSENE program and proceed to the final module, Module 5, on student activities.